Keyboard. This keyboard will work? हाँ. यहाँ से भी काम करेगा ये क्लिक करने से ठीक है. So very good afternoon or good morning now it is. Just afternoon. Good afternoon to all of you. Now because the inauguration went quite long, it has gone beyond our actual scheduled time. It was good, but then for that we'll have to squeeze this talk a little bit. And then where is Hriday Muni? I say Hriday is here. Okay. So we'll quickly go. So some part I'll be delivering, and after that Hriday Muni Kalita will be taking that part. Well, so we'll move a bit fast, and because we want to give more emphasis on the hands-on, so that you can actually walk. Okay. Theoretical part, just you take it that we are trying to give you some idea about how it actually what is the background, but then mostly we'll try to concentrate on this part. Okay. So, well, I mean, what is the need of an indigenous model or modeling software? That is basically because of high population, and unlike in the Western country, we have people residing near to river. You know, the river has various stages. I mean, hilly stage or the boulder stage, and everywhere we have people. So some of the phenomenon that our people get observed, or some of the suffering that our people face because of the river, that is quite different or much more rather than the many other countries. So we have a lot of experience on the river, how it behaves in different terrain. So that way, this is when we get this information. Therefore, a country like India, we come across and witness many flow phenomena which are not very common. Okay, to model those phenomena, we need to do in-depth study of those phenomena. What is the physical process? Then how we will develop that into equation. So those are necessary, and also we need indigenous model, because when we have our own model, we can couple it with different other model. Sometimes we can couple it with our own different model, or sometimes we can couple it result from some other model as well. That facility is also nowadays there. For example, say we were working on the simulation model, river flow simulation, and then you may be knowing that those who are working in the field, that you provide suppose spars, okay, in the river. Now that is to decide that what spar or what spacing of the spar will be most optimal, what length of the spar will be most optimal. For that, say, simulation optimization model was done by Hriday Muni Kalita long back, and there if we have our own model, and also for optimization if we can write our own model, then we can combine that, and that kind of things can also be done. Similarly, I have given some of the example like say coupling reservoir operation model with the river model. Okay, say when we are operating the reservoir, you are releasing water into it, then this is flowing in the river. So that reservoir operation model and this already we have coupled, and then you know probably that many a time that we hear about the flood and all these things in, like say Ranganadi reservoir and all those things, or various other reservoirs. Similar problem is there in I mean other countries as well, Vietnam and Cambodia, similar problem. I was working there also earlier. So now in those things we can couple both the model, and we are providing now solution to the NAPCO for this kind of problem. Okay, so by coupling this thing. Similarly, that coupling confluence of modeling and aquatic behavior, then analyzing impact of vegetation on flow characteristic. Suppose flow is moving, you are putting a vegetation, how it will behave. So that kind of things to couple. So coupling optimization with river flow simulation I have already told. So are just some of the example. So the Brahma model basically it includes simulation of vegetation, simulation of porcupine. You can put porcupine directly there, and simulation of impact of breeze and many other things. Simulation of morphological changes and so on. Okay, I'll show you some of the example only. And most importantly, which is now actually coming up in a very major way, like India should have its own river modeling software. Okay, I'm also associated with one group called GROWN, GROWN. There also we are discussing that why our own indigenous model should not come. Okay, not only in Brahma or hydrodynamic kind of things, various other hydrological model, thereby we should not have our own model. So that kind of effort is also going on. Well, with this introduction, that's why, like Hectrace we are using. Okay, Hectrace is free, of course, but mic is very costly. But now what the relation with US and India, we don't know how it progress. If Hectrace starts charging, then there will be a different situation. Okay, but Brahma will not be charging ever. So that way we should have our own model. Now, just to give you, because you are all research scholar and maybe faculty in some institute, just I thought that briefly I'll give you the history, but then considering the time, it started in 97-99. At that time, the Brahma 2D. After that, we have, as I told, the vegetation module, porcupine module, then Brahma turbulent model, so that we have, and then DRFF, that's what it is, basically 1D Brahma and reservoir coupling, so that we can use for reservoir operation properly, so that we have less flooding at the downstream. Similarly, Brahma 2D flood mapper, say a flow is coming in the river and it is going to the flood plain, then how we can see that what flood, how much will be the inundation, so that kind of things we can do. That we are doing with in a project where actually our Brahma, it's a collaboration with Netherlands. This particular project is going on, and there we are applying Brahma model for this flood mapping. Okay. So similarly, Brahma 2D sediment, so that is the sediment transport, there we can use different equations in that model. Then the latest, as we are talking about Brahma next gen, so that is basically bridging river hydraulics, aquatic ecosystem, infrastructure risks. So that kind of things also we want to club with Brahma. So that is what is actually our next thinking. And on that, actually on the concluding day, one of my doctoral student who is now in Alabama, he will be talking on that particular things. So art observation and AI implementation, all integration of those things, that is our next level thinking. Now equation, I'll not spend much time, but this is the differential equation that you can see. Basically it is written in a matrix form. Top line is actually, say U means UT, because you are a research scholar, so I thought of, telling you some of the things. Well, whether cursor will not be coming here, no? So this is basically, you can see that UT means it is basically del U del T, that suffix represent. EX means del E del X. So these are all partial differential term, and this is written capital because U is basically a matrix, and this top row, if we join, is form one equation. That means it is del S, del T, del HU, del X, plus del HV, del Y, then plus S. S means this is the source term, these are all coming, and that is equal to 0. So that way this is basically containing three equations. Okay, now I do not want that you should go in detail here now readily, but this kind of equations are being solved using a TBD macrometric scheme, and other schemes also we did use earlier, but now we are using this particular scheme, finding it's comfortable there. And then to solve this, actually these are very complex equation, so all this partial differential equation you cannot solve directly. Differential equation solution you got in your probably higher secondary level also, but in your engineering also, but then with some form you can solve it, but with some form you cannot solve it. This is not directly solvable. We solve it analytically also, but with some assumption, with some classical situation that slope is 0, that kind of things we can solve analytically. Otherwise, with complete full form, you cannot solve analytically. So we take recourse to numerical method. So in numerical method, basically, you can see this is starting from the Taylor series infinite difference. Similarly, other methods are also there. So there, if you see that when your delta x, that is the space time, and delta t, these are very small, then when it is delta x squared, those terms become negligible. Because small, suppose 0.1, then if you make it square, it become 0.01. If it is 0.01, if you make square, it become 0.0001. So that way this term become very small, and that you can neglect, and finally you can get it in a difference form. So this way, when we make it, I'm just showing you the 1D form, as is the pictorially easy. So with the partial derivative term, we express in different ways, and then we can get it in a simpler form, in numerical form, and that we solve. But again, when you see this one, you will be understanding, being research scholar and this thing, that these are all in Cartesian coordinate, means x, y, and then locations are given in the x, y, z coordinate kind of thing. This is XY coordinate. But your river will not be like straight, it will be in a curvilinear form, okay. So if the river is curvilinear form, but your equation, this you can solve in a suppose Cartesian coordinate system, then you need to convert it into a straight form first, and then you solve it again. The result will have to be converted to other things. So that means what I just emphasized, not going in detail, a lot of mathematical transformation and then solution are inside it, which we do not see when we run the model. For example, say this is a curvilinear one, then it is suppose XY coordinate, then we get it to Z, eta Z coordinate, so it becomes straight, and then we solve it. Then how this form looks, I think Hiroemoni Kolita will be showing in his presentation that again equation form will be becoming different. So that actually we use. And then now I'll quickly talk about how much is the time, because 12:19, okay, up to 12:30 if I talk, okay. So this is say application of hydrodynamic model, that I will show some of the applications what we have done in versatile situation. So that this is the Majuli area, if you are familiar to that, the river island where a lot of erosion and a lot of things happen. So these are the red lines are the basically spars, and we practically measured in the field what the velocity is, and we found that this kind of circulatory current comes, and then when we applied the Brahma model, we collected data initially, and then we found that this kind of circulatory current we could observe there, and velocity and everything could be matched. And in the vertical direction, actually for erosion and all those things, how the velocity is changing in the vertical direction, this is also important. That means vertical profile of the velocity, because in the lower part the velocity is high, as you can see. So these are the observed value, and that our model is not three-dimensional, it is two-dimensional, but it is quasi three-dimensional. That means in 2D you can have X and Y direction, and vertically how it will change, that we can do, but that is not yet incorporated in the software that we are giving you now. But then we can do the quasi 2D by different form, that at every point if we get the average velocity and the surface velocity, we can convert it to 3D form. So for that actually award was also obtained by one of my students, and then some publications are also there. So I just put those things there for your reference. And then similarly, this is another case in Tiding River in Arunachal Pradesh, very interior area, where actually bridge was constructed and bridge was washed away 5 times. And it is the China border area where it is extremely important to maintain the road, okay. But then if bridge is not there, our army or anything cannot go to that side. So that was given to us. We applied our Brahma model. This is in 2000, I think, I don't remember the year, but several years has passed. And then we applied the model, and then we saw that what is the maximum velocity it can come, very high velocity comes. So accordingly we provided the system, we make the breeze quite open, and that way means it was with abutment only, without any internal pier. So finally that was constructed, and that is resting till date. I mean several years has passed. Earlier every monsoon it was washed away. So this kind of achievement we got in practical field as well. Then this is a braided river with water resource department we did. They were proposing that some porcupine screen need to be placed. So as we have the provision of putting porcupine screen, so when we put porcupine screen, how the velocity is reduced with and without porcupine screen, so that kind of things was done, how the velocity vector changes. Accordingly we could suggest that how it should be. Similarly, this is also another work done with water resources department, where you can see that Majuli Island is on the other side, and here the dotted are actual some of the screen, porcupine screen, and that shows how the velocity will reduce, so that we could model, and we were providing those things. There's finally with water resource department some publications also came on this particular work that I will be showing later. And this is what is the our Brahma DRFF model. That is basically in NAPCO we are implementing that. See how the flow is, if inflow is coming, then how it is going to outflow, how it is outflow is happening, and when some release is made, so that they are using there and to forecast the flow. Well, these are how the level is coming, so that also we can find. So then in the Nihari, as you will be seeing tomorrow, so this is one area where the experimental study was done. It is again Majuli area, Nimati side. So how we can reduce it, some experimental studies were done, and based on that we are also working on the mathematical modeling, and then we could see that if we can design a channel or bypass kind of things, it is possible to reduce the velocity on nematicide. Of course, practically making is very difficult. Dredging of the river at that point is very difficult, but then still study shows that if proper equipment can be there, so where the dredge channel can come, so those were identified, but equipments are necessary, or implementing equipments are necessary for that. Similarly, this is a eco-hydrology study. Eco-hydrology study means this is a Bugdoi river in Upper Assam. There were a lot of fish habitat were there in this particular river, Bhangun fish, which is very popular, but gradually the fish population came down. So we found out that with our model, so for a particular fish, they like that where we are comfortable. Similarly for fish or any aquatic life also, there is a comfortable zone. That if depth is this much, if velocity is this much, this is their comfortable zone. If your depth is very high, then it may be not very comfortable for that particular variety. So the fish population went down because of some structure constructed upstream. Then we model it, and then we found that these two lines are very important. You see, total flow area is increasing with increase of discharge. When your discharge increases from 0 to 100, your total flow area is increasing, but habitat suitability for that particular species has come down beyond a particular level. So that kind of things also we can apply Brahma model for eco-hydrology kind of things, and this gives a lot of idea about what the practical situation. Then we found that at downstream, this kind of a better situation is there where you have the good habitat suitability. So fish actually migrated to those areas. So when fishermen could get to know that things, then they could, catch their fish in from those locations where habitat area is better. So that kind of, things also it is helpful. These are all published works, so I'm just putting it. It was in American Society of Civil Engineering. So these were published. So now if you see here, how the Brahma model look like, of course that you will be seeing, this is in Majuli area. It is not working. Somehow it is not working. Anyway, this is I was just showing a animation video how it works, but somehow it is not showing. Then we worked on vegetation. How we can incorporate vegetation, and with vegetation you can see how the velocity is coming down. The red spot are the velocity that is with vegetation, and blue are the without vegetation. That way you can have in Brahma models or this kind of curved channel also you could see that how vegetation could reduce the velocity. This is the initial stage. After that this work was also published, and that way it was appreciated, and then we could actually apply that the vegetation in different form. You can see on the top the vegetation is put in a gridded form, in a square grid form, but in the middle part it is in an interlaced pattern. Green spot are the vegetation. Then in hexagonal pattern also we can put. Now if we put different form, the vegetation if we put in different form, how the velocity in the river will be changing. So which pattern is most optimal and which can reduce the velocity, that kind of study also we could do, and that way we could see that with interlaced pattern or hexagonal pattern, velocity reduction is much higher, and that way we preferred that. Accordingly, that was applied in Majuli Island, and this work was also published. Then later there was a request that can we incorporate GIS, that people want to do a particular part of modeling. Then say if we put a particular, suppose we want to get the Umanando area or any area, if you type there in this point, then it will automatically just take you to that part, and there you can draw your grid, and you can even now recently we have done the DEM also can be got directly from the available DEM. So that kind of things is also included in the Brahma model now. Like this, the DEM you are getting, then the cross section you can check at different point, but then this is the actual DEM. This is not the DEM downloaded. This is actual survey DEM. So we are getting the exact cross section. But if you get a DEM downloaded from different site, there is one problem, that river level, where the river water level is there, that part you will not get the actual DEM. So it will underestimate the flow area. So we have also incorporated a method where actually if you give a particular depth point, only maximum depth at a particular point, it will automatically generate the nearly equal DEM. So that kind of applications are also included in the Brahma model. That will be demonstrated Then turbulence model, that is I have already shown the turbulence part. So this turbulence model was applied, and that way we could see that how in different area, because of turbulence, how the depth can be more if there is a high turbulence, and how velocity can be low, and how this thing can influence the flow. This is what another study that is going on, and these are all publications. As you are a research scholar, you can go for all these kind of things. Then image processing in visualization, like that vegetation, how will you give? So if you give the vegetation image, then it can be masking, and that way it can directly take how much is the obstructed area as such, what will be the change, roughness parameter, those will be coming automatically, and that you can use. So that Anurag was working at that point, and then he will be showing all those things. And then similarly porcupine, this was also done in collaboration with Water Resource Department. And then this, as I showed, the porcupine we model like this, that you can see the resistance, and this is the Majuli part that on Nimati side. And then this work was quite quite good. We could see that actual measurement was done and how our simulated things came. So it was coming quite close, and this work was also published actually. It was a joint publication with Water Resource Department, Assam, and IIT Guwahati. So these are the things that we are starting collaborating with various organizations, various field people or field organizations, which is very common in abroad, but we do not have that kind of forum actually. But now we are starting, and this is happening. This was published in 24. So these kind of things, and sediment transport, lot of sediment transport equations are there. Some are for gravel, some are for sandy, and those we implemented, and initially we tested these things for various other data obtained from literature, and then our model could capture those things very well. You can see the dotted points are the experimental data, and our this on the left side, this is the red line is our computational, our model prediction, and here the dotted is this one, and this black line is our computational thing. So that way it could predict it well, and then we applied it to Siang and Divan River, Majuli, and various other places to see whether our model works there or not. And recently we are doing in Divan and Siang also, and in there we are also observing data how much actually bathymetry has changed because of the movement of the sediment, and that part was also compared. So that way we are gaining confidence more and more as we are progressing ahead. Similarly, as I told, that flood inundation, if it happens, then hazard, how we can just calculate the flood hazard in the floodplain. So that also we added to our model, and as you can see, this is the flood hazard map basically with different discharges. If your discharge increase, you can see the flood hazard is increasing, and this is without embankment. If embankment is not there, then for 2000 discharge it is in Becky River, and then 5,000 discharge or 10,000 discharge in Becky River. How these things are changing. You can see hazard is increasing in a quite high when it is 10,000, and this is without embankment. When we have the model, we can remove the embankment, or we can put the embankment. Without embankment, this is the situation, but with embankment, you can see the hazard level is coming down in 2000 and 5000. Of course, 10,000 still it is coming down in some portion, but other portion still hazard is there. So that way with different, when we have our own model, we can do different kind of works, and that's why we are just trying to develop it as much as possible, and we every day on a regular basis we are trying to update it. And with your support, I hope that it will be possible to take it forward. Okay. So achievement wise, lot of publications, as I have already shown you, lot of news articles are also there. Then about the Brahma model, many things are there. Awards also there on behalf of my research team. I had to take the award there. And then this is another point, whether it works or not, I do not know. Video will be running here. Anyone from computer board? So it was an interesting video. Somehow the video is that is a project in Majuli actually. I don't know why. Huh? Like chotu of kurile hobo pare. Anyone? Because their people are not there.
Oh, here cursor
Cursor is not there. this is cursor is there, but then still, no, this is the video. This should be clicked. This here this tab is actually not coming. Now somehow here it is not getting displayed. It video to nosole niki. PPT to আছে. Anyway. Anyway, this is basically that in Majuli we protected a particular reach with bioengineering method. As I showed that what is the pattern of vegetation, how much velocity coming accordingly, we design this particular system, and then after designing in a very flooded area, we in a very flood time we visited that area, and then we met the people. We did not carry any video or anything, but then I just had to do selfie video. And then there the most important point is that people were so happy about this, and they were telling that why don't you extend to even further downstream and all part. And so they were actually so much of happy, and that is their happiness is actually our happiness. And after that, of course, Water Resource Department FREMA is also giving some project in this kind of bioengineering where we will be applying our model, and we will be actually solving some of their site conditions also. So with that, basically, as it is not coming, I will have to stop here. Somehow it is not working. So this is the Brahma team, but this is not all. I mean, there are many more are joining, like Amlan Jyoti Sarma, Pallab Kulta, and many more are there. So this is just some of the people who are very wholly involved in this. Bandita is also there in this group. And then with this, I always acknowledge my PhD student who has contributed directly or indirectly in this all this different kind of work that I have shown. So I am very thankful to all my PhD student and project staff. And so this is what is I wanted to again thanks the funding agency from where different funding agencies who has contributed for various other work, but where we have it is indirectly connected to Brahma model as well. So thank you very much. Thank you all. And now I think I will leave the platform to Hidayamani Kolita. He will be explaining how in the bend how these things can be done. Okay, thank you very much. We have to be hurried a little bit. To हो गया है, वो वीडियो नहीं चला, लेकिन मैं ढूंढ रहा था आपको. अभी इसका होगा.